So I want to say something about the language family classification of the world, and some ideas about how to get deeper, which I'd very much like your input on, especially from the non-linguists, but also from the linguists. So language families, to recap, what are language families? We start out from 7,000-ish languages in the world and only count the spoken ones that are somebody's mother tongue. And then, out of these 7,000, it turns out that some of them resemble each other much more than chance. And we think that that's because they stem from a common ancestor. And that's really the definition. If a set of languages stems from a common ancestor, that means they're the same family. And so occasionally you also have languages which don't resemble any other languages of the 7,000 that we have. And for those, we have the word language isolate. You could also say one-member family. So just as an example, apologies to the linguists that you already know this. So here I have on the rows, I have the same meaning, and in the columns I have different languages. So and they're written in IPA, International Phonetic Alphabet Transcription. So you see that there are some languages that the words in some languages resemble each other a lot and some don't. So maybe if you want to judge resemblances, you come up with something like this, or this is what the linguists would do. So the ones that are colored in each row in the same color would be, essentially the same word that resembles, but the resemblance is too much to be due to chance. So you see that there's, for example, the one on the left and the one on the right, you might even recognize the languages. They resemble each other a lot, and that's much more than you get by chance. So they definitely, it's good prima facie evidence that they belong to the same family. Those are the actual languages, if anyone's curious. But the point is, it starts from comparisons like this, and to note that some languages are just much more similar than what we get by chance. And usually when people say that, they mean particularly in the vocabulary. And there is this thing called regular sound change, which means you have a sound change, but it affects every vocabulary item in the lexicon of one single speaker. And that's a really good way to distinguish between chance, because if you have chance resemblances, you shouldn't have this property that a K always corresponds to a specific sound in another language. Chance resemblances you'd have in this word, they have this resemblance and so on. So typically resemblances between languages that are used to establish families are vocabulary, where you have regular sound correspondences. Then you can be pretty sure that they're not due to chance. But it could be anything else. I mean, it's also popular to, let's see, there's Cesar, good. Let me move this. Okay, now it goes away. It could be like a whole morphological paradigm, so the conjugation pattern, that's similar. That, just like anything else, could be probative. And occasionally you have something that's really unique, really uncommon feature that you have in the grammar of one language, and then you find that in exactly two languages of the world, and then that's some kind of argument that that couldn't be chance because it's such an unusual property. But there's no really precise characterization of how much similarity and even what kind, and how you should actually count that. So you can put in a formula to say, okay, these things are more similar than chance, and these things are less similar than chance. Why don't we do it? Well, it would be difficult to do. I mean, to be more similar than chance has to do with how many comparisons, how many trials you do. And so if you compare language A to language B and language A to language C, and then people usually don't report all the trials they did. They just report the successful ones. And then they don't say, what system of correspondences they were trying when they're measuring resemblances. Maybe they were trying only sets of correspondences where every sound corresponds to exactly the same sound, or they were doing something similar. Maybe all the dentals correspond to all the dentals, and so on. So it's not just a matter of putting it all into a formula to say what is beyond chance. It's the state we're in is it has to be judged sort of from case to case, and there will be disagreements. Before we get to these disagreements, I mean, the basic model for language families is that they are descent with modification. So you have something being passed on to generations, and it changes along when you pass them on. And then you can have split events. So one language turns into two. So that would correspond to the case where a population goes in different direction and accrue separate innovations, like in this tree. And of course, a language can die out. So we have the tree model. There's also language contact, which is real and it's significant, but let me just ignore that for today for convenience, because things get more complicated, but not because I don't think it's real. So then it turns out that language changes at such a pace that after a while you have so much change that you could never recognize what it was from the beginning. This is, I understand, different from, say, genetics, where you have a whole genome and it's like humans and bacteria have like 50% or something of their genome still in common. So you never get down to zero for living things. Now, with language, you do get down to zero, and at some point, people think that's something like 10,000 years, but that's like 10,000 years of separation. So if A and B are two modern languages, then if this is like more than 10,000 years ago, I probably couldn't recognize that they're related. But that's like the amount of change is then actually 10,000 years plus another 10,000 years. So maybe 20,000 years is what you get to if you start out from a language on a deserted island and then you let it change until you can no longer recognize anything from the beginning. 10,000 years is what people say. It's like informed speculation. There is no good specific argument theoretically of where that sort of constant comes from. And there should be of a stochastic nature, like sometimes language changes a little bit faster, a little bit slower. So it should be a stochastic thing, not a constant like in physics. Also, even if we don't understand what it is, it's not like it's based on a good set of empirical cases. It's a rather narrow set of empirical cases with estimates around it. But still, if it's not 10,000 years, it's going to be something else in that range. Also, I mean, one could argue that if you have this case, if this is, you need 10,000 years for it to lose the resemblance that was there in the beginning. What if you have sister languages? Could you get more? Because if you have two modern languages, you can get down 10,000 years. If you have two modern languages that relate in a subgroup, maybe you know something about their proto-language, and that's older than zero. So maybe you should get, the more you know on the broad side, maybe you can know a little bit deeper, because then you have some knowledge of stuff that happened more recently, and hopefully you can go 10,000 years back from there. But then there's always uncertainty of what happens in a sub-proto language. But I mean, you could make that argument that it shouldn't be. This time limit should depend a little bit on how much intermediate information you can get. And of course, for a number of languages, many of which are famous, you have written attestation that goes back, say, 3,000 years, or I think 5,000 years in the worst case. Well, then the limit should be from there. So you get 5,000 years plus 10,000 years is what you would have as some kind of limit of relationships that you can discover if these things are true. But it's only like a small minority of languages have old written attestations. But those cases are more discussed. So one can get the impression, if one is not a linguist, that we have a lot of languages for which there's old written data. That's not the case. It's just a couple of hundred out of 7,000. So what you're really doing as a linguist, and when you figure out which language families are, is like language goes back to at least to anatomically modern humans, which my colleagues from your disciplines say is like at least 3,000 years. Language might go back even further, Neanderthals and so on, but at least 300,000 years. And I'd say that the temporal limit is something like 10,000 years for what you can discover in the language. Well, everyone thinks that language like evolved once, So there should be like a whole world tree. And what you're doing as a linguist, you're like getting only the treetops in the last 10,000 years. You're like cutting the real tree at some kind of limit t, and you're not getting any of the relationships that probably exist underneath. So now for the $1,000,000 question, there's 7,000 languages in the world, how many language families are there? And to be specific, I want you to say the number of language families plus the number of isolates. And an unambiguous word for that is lineage. So who thinks it's 26? No takers. 251? 422? Any takers? Yeah, some. Okay. These are all real estimates, so you can see that, and these are estimates by linguists, and who claim that they're using this sort of the same method. So there is subjectivity involved, otherwise we wouldn't have this discrepancy. Nobody's denying that. So these are the people who have suggested the different ones. So you have the extreme, in that case, Rulen thinks there's 12 families and 4 isolates. And then you have Ethnologue, which is compiled by a missionary organization. So they try to get decent information everywhere, but they have no stake on their own on this question. So that's one reason why they might achieve some objectiveness. Then there's Campbell, who's a linguist who's invested a lot of his prestige in demonstrated language families, but you can see that he's oscillating like from 250 in 1999, and then it becomes more, and then in 2020 he's almost at 400. So okay, he gives some kind of disclaimers earlier on, so they're not entirely comparable, but still you see the difference. It's quite a big difference, 250 to 400. And then there's a glottolog, where I'm the main contributor to this question. I think it's 239 families and 183 isolates. So ideally, these disagreements should be solved by the normal procedure, namely you go look at the linguistic evidence and then you decide, again, who's right and wrong. But I think there's also some other meta properties that you can look at to get a feeling for what's a reasonable number and not. And it has to do with the fact that a reasonable method should be actually achieving, cutting the real underlying world tree at some height. But for those of you not familiar, let's just look at geospatial size. These are 10 largest language families. So you see you have big families on lots of continents, and they stretch from east to west and whatnot and yada yada. That's just a little bit for orientation. The most famous one is the blue one, Indo-European, but the other ones are just as interesting. Another way to measure language family sizes is not the geospatial size, but the number of languages contained. And this is the top list from the glottolog classification. So it's the biggest one is 1,400 languages in it, and the second biggest 1,200 languages, third biggest 780 languages. Yeah, you see, and it quickly goes down. So this is just the top. What is it, 15, 20, and it goes down quickly. So if the total is 422, you can see that if it keeps going down like this, that there's a really long tail of small families and isolates in this number 422. Here is Ruland's 16 families or 12 families and 4 isolates. So you can see what his families look like geographically. So you have things that span exactly the Australian continent, and things that span exactly the southern half from North America down, except for the Navajo branch of Nadene. Yeah, exactly 4 language families in Africa, and so on. The point here now is that if a language classification that linguists does really is cutting the treetops of an underlying tree, then the family sizes should have something to do with the birth and death rate that is underlying the real tree. So languages split and sometimes they die. Depending on how that happens, you should get different kinds of underlying trees. And when you cut the treetops, you should get different size families out. The most common process people use for estimating birth and deaths in a tree process called the Galton-Watson process. It's very simple. You have a death probability and a split probability. There are many more complicated models for how you might stochastically, split or die in a tree. But to cut to the chase, all the interesting, reasonable ones implies that you should get like a power law distribution on the number of languages included in the families if you then cut a tree that was generated by such a process. So power law distribution is when you take the biggest one, rank biggest, and then maybe that has 1,000 languages. Then that means that the second biggest one should have about half of that, so 500 languages. The third biggest should have 250 languages, fourth biggest, 125 languages, and so on. That's a power law with the constant 2, so they should halve in each rank step. It's also power law if it's not they don't halve, but maybe a third or some other number. And that's, in contradistinction to, say, a normal distribution where you have that most families have a certain size, and then you have equally many families that are this much bigger and this much smaller. This should also, play along not just on the exact treetops they get, but you get internal subclassification of the treetops you have. They should also sort of match the general birth and death process that is underlying the real world tree. And also you could argue, you should, if you have an enclosed area, which is big and with old occupancy, so beyond this temporal limit, then you should have the same kind of power law within that area. So for example, in Africa, you should have the sizes just in Africa should also obey a power law, because then you can argue that the same process should be playing out. So what do we actually find? This is, oops, the numbers actually, let me know. This is a shame. Yeah, anyway, in Ruland's classification, you have the biggest families like 1,600 languages, second biggest family, 1,500 languages. And there are not so many families, and they're all big, and then just a few isolates. If you do log on the rank size plot, if it really is a power law, then you should get a straight line on the right there. You don't get a straight line in the Ruland's classification, which means this is probably not the result of somebody cutting the world tree at a certain temporal depth. If you look at ethnologue, on the other hand, it really nicely fits a power law. And if you look at glottolog, you get the log plot gives you an R of 0.99, which is an extremely good match actually for a power law, and it gets just a slight tad bit better with the glottolog classification. So already from this, without knowing any linguistics, having these mega families, many mega families and a couple of small families is just not a realistic outcome of a consistent procedure that is trying to discover relationships that come from a world tree which has stochasticity in when things die and are born. So that's sort of an outside check that one can do, which I think is reasonable. And I mean, it can be redone. Sort of, if you look at this, exactly 4 families in Africa, it's really unlikely. What you get is you get one big one, and then a second sort of big one, and then a long tail of small ones. And that's not what they get in, like the enclosed area of Africa. Really unlikely that you get exactly one family in New Guinea, exactly one family in Australia. So something for this reason alone is probably not right, at least if you consider the temporal depth of settlement of Africa and things like, and New Guinea for that matter, also Australia. We move to something else. What about documentation? So I say there's 422 language families and 7,000 languages. Well, you might have heard that most of the languages in the world are not documented. Yeah. So if they're not documented, how can you expect that you get the true comparison? How can you imagine that if you, with such poor data, that you get all the relationships that actually exist? So, I mean, there's one trivial thing to say, well, sometimes a language isn't even known to the scientific world. Yeah, as more and more languages become known in that sense, documented in that sense, well, then, of course, the number of language families should go up. If you have more things to classify, there will be more groups. That's trivial. But then there's the other one, like if the language is already known, and then you get more documentation on it, should you then expect the number of families to decrease because now you have more documentation, so you can find more similarities, so you can prove more languages are related. So that one is more interesting to look at empirically, where it's the case. So if we first just look at what is the current state of documentation of the world's languages, I play around with this scheme where I count for each language the most extensive description of that language. So typically you have, for one language, you have one thing, grammar from 1920, and have your longer grammar from 1980, and you have 3 word lists from 1850 and so on. All of that together should ideally be added, but here I just focus on the most extensive one for each language. So with 7,600 languages, about 23% have like a long grammar. That's a 300-page thing that tells you like everything you need to know about the language in many senses. And if you don't have that, you might have a grammar which is like 150 pages. That still tells you a whole lot of things. And if not that, maybe a grammar sketch that gives you the basic features on like 50 pages. But if you don't have that, maybe you have a description of a specific feature or the pronoun system in that language, things like that. And if you don't even have that, then you might have, that's the most common thing. You have a list of like 200 words. That's the category of word list. To make sure that the language exists and whatever you can say from 200 words. It might even be that you have less than that. So you just have a paper that says, this language exists. It's a different one from other languages in the area. Here are a few more things, but not like a systematic list. Or even a language that doesn't give you any information how to say anything in that language, just the fact that it exists. So you have like 25% of the world's languages which are like this, known only from word lists or even less. And obviously, in the past, there were fewer languages documented, so we can compare classifications between the present and the past. I also play around with putting numbers on that. So I give 5 points for long grammar, 4 points for medium-sized grammar, 3 points, and so on. And then if you take the numerical average, 2.84, if one wants some kind of number as to how much of the languages of the world are documented as of now, well, the max would be like something like 5 then in this scheme, and it's 2.84, so half done. Before I move to the real question, I want to point something out. So if you count the most extensive description for each language, it's like 1.7 million pages. Sometimes people say there isn't objectivity in these language classification things that are global in the world, because you can never have an individual who knows the whole world. It's true that you can't have an individual who knows everything, but it's not true that it's like humanly impossible to, for example, read the most extensive description of each language. You can do it in like 10 years. And I know people in this room have spent 10 years reading about just one family. So, it's perfectly possible. And this is conservative too. You only read 8 hours a day, but you need sleep, but you can eat while you're reading, while you eat, and so on. So probably, and you skim half of them. So it's perfectly possible to have a global view. You don't have to be super human. So this idea that you cannot have consistency because no single person can overlook that part of the world, that part of the world, it needs a little bit of perspective. It's still, of course, true that you cannot know everything. You cannot know everything about every possible argument that's been made for every language. Okay, how did this change in 1700? Here's a gray dot for a language that we now know to exist, but didn't know existed. And then I have like orange and orange dot for grammar sketch, green dot for long grammar, and red for like word list. So the more green, the more documented. And in 1700, it was just a few things in Europe which had longish grammars and things to which missionaries in the Americas and a few other places. And then, of course, 1850, we get colonialism, we get more documentation. In 1900, starts to get greener, various places. Some places are still very unknown. 1950, okay. 2000 and 2020. So what can we say about this? Well, it's obvious that there isn't, one area where we know nothing about the languages. We know a lot about the languages in all areas. It's just a matter of degree as to how little and how much we know that you can get from just eyeball comparison. And so here's like the rate of how documentation increases by year. And you see that, in 1500, not much happened, but stuff takes off from 1850. And then it's like almost the same rate ever since that time. You can like calculate how many average description points happen every year. And then it's, in this 0 to 5 scheme, it's 0.027 description points per language per year. And that's like 40 new long grammar equivalents per year. Something like this is the rate that we're going on. And if you play that out to the max, the max actually isn't 5.0 anymore because some languages are dead. The max is 4. What is it? Oops. Let me move this thing. Mm-hmm. Oops. Anyway, where was it? Okay, not that thing is max is 4.68, and we will get there in 2084 if the pace is the same and none of the language die in between, which is unrealistic. But anyway, okay, now we compare what kind of classifications you would get, in the past when most of the languages. Where did it do that?
I don't think you need to share the screen. It shares anyway.
Okay. So I can do this just, yeah. Good. Okay, it would take a long time to compile all the cases, but there's, from the Americans, very clear cases. Chesmilo Kotka submitted a book in 1964 where he did a classification in South American language. He said, I'm only going to do my classification on basic vocabulary because, I don't have time to do it any other way. And by the way, there's only very few languages out of the 400 or 500 that he was considering that have more data. So he did it only on basic vocabulary. So he did it only on what the category word list there is. And then in 2012, Campbell did a classification. And by that time, the number of long grammars and grammar sketches had gone from 94 plus 46 to 190 to 233. So if documentation was really a key to finding more relationships, you would expect there to be much fewer families in Campbell's classification from 2012. There isn't. It's actually almost identical. And that's also the glottal classification nearly identical to that as well. So no, a lot more documentation doesn't lead in any direct way, at least not empirically, to more families being recognized. You can say the same for North America, where you have a classification from 1891, and that guy was actually. It's true that at that time there wasn't so many grammars that he could use for North America, but he was ideologically against it. He said, no, basic vocabulary is the only thing that counts. So he wouldn't have used it even if he had it. And that's in 1891. And then after really intensive study of the North American languages in the 100 years intervening, Goddard's classification from 1996 is also nearly identical to Powell's from 1991, and also nearly identical to that in Glottolog, despite the fact there were shitloads of more documentation happening, and also actually a lot of investigation into the relationships of these languages. In South America, you could argue, well, there was documentation, but fewer people who were trying to look into the relationships. In North America, you could never say that. And you could repeat these cases for other areas of the world as well. So I would argue, like for language classification, you only need pretty much a word list, and that will get you approximately right. So some things will change, of course, with more documentation, but not dramatically. So then we would have seen dramatic changes in these American classifications. So yeah, you can discover more things if you have a lot of documentation, but most of the things are already there in the word list. Now, what about going beyond this? So if language changes at such a pace that we no longer recognize the relationships after 10,000 years or some other number that you prefer, then is everything lost? Well, I mean, one thing is there weren't any helicopters 10,000 years ago. So you'd think that the closest relative of any language would be pretty much near it. So you don't have the closest relative of an Australian language in North America and things like that. And even, you know, the closest relative of any language should be pretty close, because that's how people moved in prehistory. And everyone has understood this, obviously. So everyone, you know, when you compare language, you look at the neighbors first. But I'd like to contribute at least a quantification of how often the language is even a neighbor, and so on. And if genetics and languages go together, you could just look at the genetics, and you get that goes back much further than 10,000 years. So as long as you're sure that you're looking at genes which somehow travel together with the language, then you get the language as relationship as a side effect. Now, it isn't true that genes and languages always travel together. Sometimes they do, and sometimes they don't. Sometimes you get gene flow, but no language flow. Sometimes you switch language. So, but wouldn't it be interesting to know, like, a number of how often do genes and languages match, and compare that to geography, say? And then, of course, archaeology should be the key discipline in this to suggest which things 10,000 years ago were more similar to each other and which were not. So here's to address this question about geography. I don't have polygon data for all my languages, but I just have center point coordinates. But if you do the Voronoi regions from those coordinates, you get a map like this. So you get a pseudo extension of each language family. And as you see, I mean, most language extensions are small. So whatever defect these polygons have from the real territory that language occupy, on a global scale, it's not going to make a huge difference. So I think that's enough for judging this question. So you see here the 7,000 languages and their regions. Then there are a couple of things one could ask. Let me move this thing again.
Don't click there. Don't.
Oops. Thank you.
Now you can try. Oh.
Let's put it here.
You can also hide it if you want.
Ah.
If you go to more, or Control Shift H or something.
Hide floating meeting
Control Alt.
I wish I'd known.
Shouldn't be
Okay, it's just an example. You have a language family Central Zonic, and you have a branch of that which is called the Membi Mamut F, yada yada yada. And you see that there's the orange ones on the map, and the ones which have filled polygons are the ones you can see in the tree. So you could ask, for example, these are immediate sisters of each other. You could ask, for example, ask Lesse, how often is your phylogenetic sister, one of the phylogenetic sisters at least, a neighbor to you? Yeah. Or you could ask, from no, it's coordinates with a whole family. So you could ask, is one member of this whole thing a neighbor of no? Or you could ask, you could, for example, if you take any of these languages, okay, how often is somebody within the same family a neighbor? Do I have the number? So, what are your intuitions?
Hi.
Hi. I need numbers.
What is
Okay,
the
they should be
what kind
ranked.
of
So
number?
that one's more difficult than that one. That one's always easier than that one. You have hi. You have what?
How do I express this in what kind of numbers?
70%. That's it.
Okay.
Yeah.
The last one is 97%.
Yeah. So that's the same question as saying, are language families geospatially coherent or are they cut up? Yeah. So 97 on the last one. Okay.
60 on the first.
60 on the first, and then
That's
average of that.
83.
Yeah. Yeah, you have great intuition. So it's 54, 71, and 93. Yeah. But that's an amazingly strong prior, right? 93%. So you almost don't have to do any linguistics. You can just say, well, name, Swedish is going to be close related to one of its neighbors, and it is. Yeah. So, but how does that help us knowing what something that was 10,000 years ago, what's the closest relative of that is? Well, then it's a little more bleak, right? Because first of all, whatever sister you had 10,000 years ago, would that sister still be alive? You can play around with numbers and that, but so one way to get an estimate is to say, well, there's 422 languages that lived 10,000 years ago that still have a reflection today. How many were there 10,000 years ago? Probably more than today because we lived in more dispersed groups and hunter-gatherers, yada, yada, yada. But let's just say there was the same amount of languages. So I'm not saying it's more or less. Then it should be something like 5% chance of survival. So for every language where we know it was around 10,000 years ago, and we ask, who is its closest relative? Well, the closest relative is not going to be around 95% chance. Only if you're really lucky did that closest sister also survive. Then, of course, it gets more complicated if you put in other numbers there, if you ask about not just the closest sister, but a sister, and so on. Also, 10,000 years ago, we don't know where languages were spoken. We have to guess where they were spoken based on more recent information, and that comes with uncertainties. So it can also be a little bit deceptive. So just the fact that it's always the neighbor doesn't mean that we can go beyond 10,000 years because the sisters aren't going to be around anymore. We're going to think that languages are in places which they weren't. So what about genes? Everyone knows sometimes they travel together with language, sometimes they don't. I've always wanted to know to what degree, and luckily I was drawn into a paper by real geneticists where my contribution was just to make sure the IDs are good. But it's a nice data set, 295 languages, 397 genetic populations. Don't ask me about the definition, but it seems many genetic populations speak the same language. And then 4,000 individuals, so populations are represented usually by more than one individual. Okay, so the quick question, does the closest genetic relative in this data set match the closest linguistic relative? Here's what we got for Indo-European. So you see, pretty much it does. I forget which one is on the left and on the right, but maybe you can figure out. Anyway, you see not the details, but you see the amount of crisscrosses, which would be mismatches. But also you see that there's like 10 kinds of Spanish there, so it's not, the data set is not exactly what you'd want. Austronesian, sort of the same thing, even less mismatches between genes and languages, at least in the set. But for Turkic, much more mismatches than those two. Yeah. Anyway, there is an average answer to that question. Does the closest genetic relative match? Or let's ask this. How often is the closest genetic relative of a population in this data set also a linguistic relative? I need numbers. 70,
65.
65, 50,
77.
77. But no geneticists, or maybe you're a geneticist. I want your intuitions. 90. Yeah. Oops, where was I? 82. But that's just this data set, and so I think it's inflated because if there are more mismatches that are outside this data set, they won't show. So we need much bigger data, and there's no reason why we couldn't get 7,000-ish genetics samples now that it's so easy to get it. Just swipe somebody. So more genetic data, and then we'll get a much better number and a much better proxy. But like it seems like together with if you have a modern language and genetic data and the geographic locations, you don't even have to compare the languages. You can guess which language is the closer relative of the neighbors. It seems like enough to get much more than chance, right? Okay, then archaeology. I have this database where I try to associate intermediate nodes in language trees with archaeological cultures based on the literature. And to do that, there should be some kind of signature in the archaeological record that can pinpoint exactly some proto-node. So there should be something that we know about the proto-language, maybe where it was spoken, or that there is words for domesticated pigs, something like this that matches quite well some archaeological culture. It's a risky business to do this, but you see, the kinds of cases that you can get from the literature. So I have, my list is 126 cases, but of course I don't know how complete this is. There are many intermediate nodes. I don't know if there is enough archaeology out there, or if there is enough archaeology out there, but you don't have enough identifying evidence. So in these cases, I try to filter where I think the argument is plausible that they have to be associated. But pinpointing it to a specific node is kind of a shady business, because if we take this extinct sisters idea seriously, that a lot of languages died without being around, then to say that, say, I don't know, Proto-Indo-Iranian was exactly that archaeological culture, it could have been an extinct sister of Proto-Indo-Iranian with the exact same linguistic signature, which had slightly different time depth. So that's more shady business, I think, than making the association itself. But anyway, now tell me, what can I do with these lists? Because archaeologists don't have trees that I can compare with. There's presumably a really good reason why you don't draw trees, though there's too much lateral transfer or whatever. Sure, there's a good reason, but you don't have trees. There's no easy way to compare the archaeological tree to the linguistic tree and the genetic tree and yada, yada, yada. Also, there seems to be no full list of, like for languages, there's a list of all languages. There's no list of sites in archaeology that could be, indexed by, say, space and time, that one can systematically compare with. So you tell me what, if anything, can be done with these kinds of associations between linguistics and archaeology to get at the questions. Actually, that's my conclusion, that first of all, if you have a language classification, arguably it should be exhibit like a power law, size, rank distribution. The number of language families not so dependent on documentation that you might naively think. Geography and genes are really a good prior for gauging the relative. And then my question, yeah, again, how can we use archaeology in all of this? Thank you.